Good morning, everyone, and welcome again to the Hannover Messe Hydrogen and Fuel Cells Group Exhibit. My name is Michael Sinclair, and I will be the moderator for this next discussion. Please, I welcome you to come in, sit down, have a seat. There's complimentary beverage service, and please enjoy the next talk. I'd like to remind you that audience questions are welcome at any time, so if you have one, please raise your hand and I'll bring the microphone to your table. Here to join me to speak about from prototyping to high precision technology for microstructure plates, we have the Authorized Manager of New Technologies from Gräbener Group. Please join me in welcoming Mr. Achim Edelmann to the stage.
Hello, good morning.
Yes, thank you.
Good morning all together.
Mr. Edelmann, welcome. Please maybe start the discussion. I see you've got a sample. We'll talk about that in a minute. We'll start the discussion with an introduction to Gräbener.
Yeah, hello. Thank you first that I have this chance here to sit here and talk to you. Gräbener company is a private-owned company founded in 1921. We are dealing since 1984 with a hydroforming technology, a very high precision technology. We can say that we're one of the pioneers in the market and have worked with this technology since this long time. Since 2003, we have supported and we have transmitted this technology for the production of very high precision microstructure plates. And now we are in the position that we can offer several services. But Gräbener itself, it's not only dealing with the hydroforming technology, we are coming from the metal forming, metal working company. So we have different business units, but I don't want to explain them all today because we have a limited time frame. So what I want to do is concentrating, and that's what we're doing in the hydroforming business for the fuel cell, for the electrolyzer market, and also, let me say it more in general, for the microstructure plate market. Yeah?
Very good. So I'm curious about hydroforming technology. What are its advantages over, I guess, a stamping would be another alternative. Why hydroforming?
Yeah, let's talk. It's a small story. Hydroforming is one of the methods to bring metal in form. So using simply water and press the water against the form. Yeah, like for doing it for several purposes. We have looked on this technology and found high potential to bring very thin materials in form. And customers who want to have metal structure plates, they are fearing that the initial costs to come to a first sample. And so we have invented a method for making this barrier very low. So the customer can have the first samples for a comparatively low invest for the beginning, but directly with a very, very high precision, which is necessary for half this. Yeah? So hydroforming, we call it as a kind of a bridge technology for getting customers who want to have metal in their hands, like I have it here. Yeah? Metal means microstructure plates with a high precision, ready for mounting, yeah? But with a comparatively low initial cost in comparison to other fabrication methods. That is what we have to say.
And what do the microstructures do in the plates?
The microstructures, can be part of a fuel cell, they can be part of an electrolyzer. It is in general, it's a quite high volume part because the microstructure plate itself, it is necessary to bring the fluid in the right condition, in the right place, within this fuel cell stack or electrolyzer stack, however. And to operate it, you need many of them. You put them together, you stack them, you press them together, and then you have a functional fuel cell stack. Yeah? So that is the task which the microstructure plate has to do.
Hydroforming, is it only appropriate for that low volume production, or is it also equally I guess, viable at high volumes?
if you look on the real process, everybody is starting with a low volume. And he want to have, for comparatively low budget, he want to have some plates in his hand, maybe some hundreds, maybe some thousands, to start his business, to start his trials, to build up the first prototypes. And then the story is going on. If the customer is successful, yeah, he need more. And hydroforming, again, in combination with our production technology, which we have invented, we can make a kind of a bridge from the first sample to a high volume and high precision mass production. But our intention is that the customer, when he has run the first successful test, he wants to have this technology in his hand to do this production by him own. And so that is what we have. That is the story. Yeah, you want to have the first sample, you want to have the first volume. That is what we are operating, that is what we can deal with and we handle to the customer. And then, when he has successful product, he has a successful testing, we can transform it to his modular, own managed production at his own facility.
I see. So if I'm developing fuel cell technology and I need a metal microstructure plate, I guess walk me through the development project or the program that Gräbener can offer for me to ramp up my volumes.
Yeah. Let me focus on that what we call metalwork. Yeah? Metalwork means everything which is in combination with forming, cutting, and welding. These are the main issues to produce such a type of working operating plate. Forming, cutting, welding means you take the basic material. It can be a plank material, like here. It can be a pre-coat material. We bring it into the form. We do the cutting, we do the welding, we do the tightness testing. And these are the basic functions which this type of plate has to do. We have to take into consideration that it's not some simple fluids which are working here. We have to take into consideration that we are talking about hydrogen. And hydrogen and tightness, I think everybody who is familiar a little bit with this technology knows that you have to cover or you have to reach a very high precision level, and you have to transfer this high precision level from the prototype, from the first samples into a reliable production. And that is, I think, that is the high task we have to do. Yeah?
But you were talking about the transition from ordering initial parts, I guess, at small volumes to transferring the tooling into their facilities. So, okay. I guess talk us through what that transition looks like from Gräbener.
The transition is like from the first contact, from the first idea. How could a blade be managed? How could a blade be fabricated? We are in contact with the customer in each steps. So for the first sample, what is necessary to do, looking on the possibility, how can we do the fabrication? Is it possible to form it? Is it possible to do the cutting, the welding? Even with a look on how can a production plant be built up. The production plant, I think that is a tricky thing, because that is the second investment which the customer has to do. Yeah? First, he has to invest some money, tool costs and something like that, to get the first sample in his hand, and then he has to do the next investment to get up his own managed factory. Yeah? And to keep this investment in a range compared to the volume he wants to produce, our method which we have developed is built up in different modules. So he can order, we can discuss with the customer, and he can order a kind of a first set of production equipment. Yeah? It's sufficient to manage the first numbers, and parallel to the increasing numbers coming from his customer, we can put module by module again to the machine, to the equipment itself, to reach the ramp-up situation. So that is.
I see. So it's scalable. So initially, a customer can order samples of physical parts from you, but later you'll help integrate a hydroforming system at their production facility for them to operate, and that's a scalable system. So it can go from I guess a single tool, and then it's modular, so it can be replicated.
Exactly. That is exactly what you said. And another part of the story is, and that's what we have seen very often, you start with one geometry, with one sample. Yeah. But in the run of the project, you see the demand to make one size a little bit higher, one size a little bit smaller. So you need a multifunctional production equipment. Yeah? That is also a very interesting thing. Looking on the production technology of hydroforming, everything can be flexible. So if you once have defined, let me say, a frame within you want to work, yeah, you can do all different geometries. That gives the chance to the customer that he is not fixed only on one geometry, and he has to do the investment only for one. He can do the investment and interchange only some active parts and be very, very flexible. So that gives him another advantage in the investment security. Yeah?
What are the most common quality problems with this, with hydroformer creating metal plates, metal separator plates, and how do you control those quality concerns?
When we are talking about quality, when we are talking about high precision, the first thing, and the customer is only interested that his product is working. It should work, it should operate, it should be tight, and it should be live in the time he wants to have it. Our philosophy is that from the first part which we deliver to the customer, we achieve and reach the quality level exactly to that what can be reached in a high volume production. So that means everything, machine design, tool design, all devices which are necessary for producing such type of plate have to be according serial standards. Yeah? In addition to that, we have some measuring inside the process to get a good feeling, and not only a good feeling, a good feedback, that we reach all necessary production parameters part by part. And in addition, I think that is one of the biggest advantages from hydroforming process. I talked about the tightness testing, the tightness for hydrogen. Hydroforming is a method. We are using water with a high pressure, put it to the plate, and in our process, we have a control plate by plate about the tightness. That means, I give you a figure. If you would use 3,500 bars for forming, 3,500 bars water pressure on this small plate, and it's tight, give you the guarantee that in the normal operation condition of a hydrogen fuel cell, which can be operated with 1.2, 1.5 bar overpressure, yeah, the plate itself is tight, really. And so that is an additional feature coming from the hydroforming specific process, that each plate which is produced has directly integrated in the production process a kind of tightness testing itself. So then we only see that the following processes, like welding, are also controlled in this way. And we do it with the integrated tightness testing for the welded plate itself.
So is Gräbener supplying only the hydroforming equipment or the welding equipment as well?
If you look on the value-added chain for producing this part, we are concentrating on that what we call metalwork. That means from the part coming into the machine, the hydroforming, the cutting, the welding, the tightness testing, everything which are related to metalwork is that what we have as our core competence or the scope of our supply to the customer. So we have the complete control over this part of the process. Even we take care on the design of the plate, which is even more also important. We have to know something about the application. We have to know something about which type of sealing, which type of coating is preferred by the customer. So we can give him a kind of engineering support during the complete contact with us. That means we have several products. The product is that here. Another product is our production facility, production equipment. But the third product which we offer is the complete sufficient engineering support. So we know all about, or we know much about the influences on this simply product, more or less, coming through the application, coming through the coating, coming through the sealing, and everything like that. And we can give a very good engineering support to the customer. So from the first contact over the first part up to the facility which he wants to manage by himself.
Are there any audience questions? No, that's fine. So I guess I'm still curious about the differentiation, because I don't have very much expertise in hydroforming, that's for sure, but I do have some experience with stamping. So when would you use one versus the other?
I think according to the existing two methods, there are two technologies in the market, graphite and metallic. technology for this part. There are existing two methods like stamping and hydroforming for producing such type of parts. If you look on the initial costs, and that's again what I have to highlight, you want to have a first part, and if you will do the first part with the traditional stamping process, the initial costs are comparatively high. So that is a barrier for the customer. He's not willing to invest such a high cost of money only for getting a first sample or some first samples. That is the big advantage in the first step for hydroforming. So the tool costs are, I can give you some figures, factor 5, factor 6 lower than you have to invest for regular stamping of a normal stamping. That is the first very good argument beside the precision and the tightness testing which integrate in the process. Because everybody now who is doing some prototyping and some projects has to look on the costs which are available for such a project. The other very important thing, decision for hydroforming is you can build up your factory, you can build up your own production extremely modular according customers' request. So if you do one investment for a big machine, you are fixed on the capacity of this machine, but there are, what we see at the market at the moment, there are a lot of different shapes, there are a lot of different configurations in the market. That means you have to look on which sizes you want to produce. And so you have to keep flexible for a long period of time. And that's another argument for using hydroforming technology, because you can be very flexible and change the geometries from one to the other size with a comparatively low investment. That means, in putting it together, not only the technical issues will give the customer the choice for hydroforming, even the commercial issues, looking on the costs for the initial one and costs for the production line, will give a positive impact for the hydroforming technology.
Great. So for more information, if there's no other audience questions, I'd like to direct, if you think of a question later, you're welcome to, of course, to go to Gräbener's booth. It's located at D56. So if everyone could please join me in thanking Mr. Achim Edelmann for joining us today.
Thank you for sitting here. Thank you.
Thank you very much.
See you.
Up next in the public forum, we have Mr. Thomas Stevenson. He is the CEO and chairman of Pajarito Powder. The title of the talk is Maximizing Value with Engineered Carbon Supports.